Alright, next section is 3.3. We're going to talk about a specific characteristic of every line. Right, every line has something called a slope. Right, think of it as just some number, right, that describes the way the line's going to look. Right, think of it kind of like your shoe size. Right, it doesn't tell me everything about you, right, but if I know you wear a size 20 shoe, right, then I can estimate, right, maybe how tall you are. Right, same deal with slope. Right, it's some number. Once we see that slope or that number, we can figure out or take an educated guess as to what shape that line is going to take. Is it going to be going up? Is it going to be going down? How steep is it? Any of those things. So let's start out with a characterization of slope. Right, so just in a straight English definition, slope, if you looked it up, I would probably be defined somewhere along the lines of steepness. Right? Think of it as a ski slope, or going up a hill, or if your table's wobbly, right, and something keeps rolling off, right? You'd say this table's sloped. Right? I can't ski down that hill; it's too steep. So same idea holds in math. Right? It has the exact same definition, but we're going to progress into a mathematical definition of what the steepness means. Right? But in general, right, we have 4 different types of slopes. Right? And we'll see where those all come from momentarily, but just as a brief overview, right, we have 4 different types of slope. Right, the first one, right, if we had this line, when I'm reading a graph, and hopefully when you're reading a graph, you'll read it the same way, but we generally read left to right, so I read my graph left to right. So if I'm starting on the left and traveling along this line, right, we would be considered going uphill. Right, if I'm traveling uphill, right, we consider this a positive slope. Hopefully this kind of paves the way for the other answers here. If I have a line like this down here, right, if I'm traveling left to right, I would be considered traveling downhill along this line. So we would call this line, right, and describe it as having a negative slope. Right, 99% of lines have either a positive slope or a negative line, or a negative slope. Right, but as we just saw, right, there are those special lines, and those special lines have 2 special slopes. Right, so let's add a little bit of space here. If we have, right, a horizontal line, not the most horizontal, but you get the point. And if I have a horizontal line, think of this as just flat ground. Right? You're standing on the floor in your home. Hopefully that floor is flat, right? It's not increasing. You're not climbing uphill or sliding downhill when you walk on the floor. Right? So the slope of a horizontal line, we say, is 0. Right? There is no slope to this ground, no slope to this table, no slope to this line. Perfectly flat, 0 slope. Right, in our last example, that would be the other special line that we have, a vertical line. And that's going to have a different slope than a horizontal line. Right, horizontal is 0, perfectly flat. Right, it's right in between positive numbers and negative numbers. So 0 should make sense there. For a vertical line, right, vertical lines are no good. Right, they're bad for lots of reasons, and we're going to see why at the end of this chapter, or one reason why they're bad. Right, but the more math you take, the more times they pop up, and they always characterize something bad going on. And when we talk about the slope of this line, an undefined slope. Right? And if you remember, we've seen undefined before, right? And that's when we divide by 0. Right? That's different than a 0 slope, but we're dividing by 0. And we'll see how that happens when we calculate the slope. But right, vertical lines have an undefined slope, and horizontal lines have a 0 slope. All right, so there's our 4 types of slope. That doesn't get us any closer to figuring out how do I know how negative it is, how positive it is. How do I figure out what this number is? Right? Well, another way to do it, or another way to characterize slope, well, we'll take a look at another line. I'm not going to put it on a graph, but here's a line. It has a positive slope. I'm going uphill. But how do we know how steep this hill is? Well, how do we know how steep it is compared to this line? Right, clearly, if we're just comparing these, I could much better walk up this line than I could this line. So this one's steeper. Right, but what numerical values can we attribute to these to kind of figure out what number should be associated with it to tell me what the slope is? Well, how we do it, right, if this line travels a horizontal distance, let's call this the run. So horizontally is how much we run, and it travels a vertical distance, and let's call that the rise. And if we compare these two, we can kind of get a feel for how steep my line is. Notice this line down here, I tried to make it have the same run. Right? So if 2 lines have the same run, how are we going to know which one is steeper? Well, the one that has the larger rise. And if I have more rise, well, then my line has to increase faster. So it's going to have a larger slope. All right, so this is the idea behind how we get to this calculation of slope, is a comparison between the rise and the run. And from here on out, whenever you hear the word slope, right, it'd be beneficial just to think, first thought, rise over run. Right, so this is our go-to thought. It still doesn't give me a number, right, but it's a very important characterization of slope that we'll use throughout the chapter. So, all right, let's stick there and then try to figure out how we can actually come up with, right, this numerical value. A more mathematical way to say rise over run is nice, it's alliterative, we can remember it easily, but a more mathematical way to say it would be the change in y over the change in x. Right? Rise would be how much I go up or down, so that'd be my change in my y coordinate, and run, how much I travel left and right, that'd be my change in my x coordinate. So hopefully this characterization seems natural. It's just a more technical definition of rise over run. Still doesn't give me a number, but we're almost there. All right, so lastly, given any 2 points, right, I'll generically call these 2 points x1, y1, and x2, y2. The slope between the points is given by, all right, so here's our mathematical definition of it, right, the way that we'll figure it out computationally. Right, it's m, all right, that's our symbol for slope, y2 minus y1, x2 minus x1. So this is going to be another very important, right, way to characterize slope. This is how we're actually going to find some numbers. or more importantly, a very specific number that tells us what the slope of the line is. All right, so notice how this compares to change in y. If I want to find the change in y, or the change in anything, right? If I had 8 apples and I gave you, and now I have 3 apples, what is the change in the amount of apples, or how do I find it? Well, I do 8 minus 3. I find the difference. That's exactly what we're doing here. If I want to find my change in my y coordinate, well, I subtract the y coordinates, and that'll tell me how much they differed. Same deal, if I want to find the change in x, I take my 2x coordinates and I find their difference, and that's going to tell me how many steps in the x direction I needed to take. So, all right, this is going to be our characterization of slope. And let's look at an example real quick. All right, so find the slope. Between -1, 3 and 2, 5. All right, I'm going to do this 2 ways. Right, so you can do it either way. If I'm given 2 points, just like this in ordered pair form, I'm more likely to just follow my formula. So I'll do that first. So let's find our slope. And if it helps, you can label these points x1, y1, x2, y2. Right? It doesn't matter which one you label x1, y1, x2, y2. I could very well have switched these around. It won't make a difference in my answer. It just seems natural to call this the first point and this the second point. All right, so I'm going to substitute all these values into my formula. Be extra careful because in my formula, right, I'm subtracting. There are 2 negative signs in here that I have to keep track of. So when I set this up, I like to put the negative signs in there already. I know these negatives are guaranteed to be there based on the formula. And now I'll just put these y2, y1, x2, x1 all around it. So y2, right, y1, x2, and x1 is -1. Right, so notice specifically down here, you have to be very careful with the negatives because lots of times you're going to end up with a double negative. Right, I'm subtracting this negative, so make sure we, right, remember to turn those both positive. And we end up with a slope of 5 minus 3 is 2, and 2 plus 1 is 3. So there's the slope of our line. All right, what does that mean? All right, well, until we get a good feel for it, we won't have much meaning for it, but once we put it to a visual, hopefully it'll give it some meaning. Right? But remember, think of this slope as a rise and a run. Right? So this would mean if I'm traveling along this line, for every 2 steps I travel up, I travel 3 steps over. And we'll see that in our graph. Okay, so we can plot these 2 points. We know how to do that. -1, 3, -1, 1, 2, 3. And 2, 5. X is 2, y is 5. Would be way up here. All right, and there's a line connecting those two. Oh, there's a line connecting those 2 points. And I'll do this in a different color. If we're looking at the graph, we can find the slope a different way. We don't have to worry about the slope formula, even though we already know our answer is 2 over 3. Right, if I wanted to travel along this line, I'm going to start at one of my points. Again, it doesn't matter which one, but I generally travel left to right. So I'm going to start at my left point. I'm going to say, well, how would I get to my right point? Give me some directions. Right, and the only directions you can give me have to be rise and run. You can't tell me that you have to go diagonally this many steps. We can't count diagonal steps. We can just count vertical and horizontal steps. So if I'm going to travel from this point over to this point, I would have to take 1 vertical step up, 2 vertical steps up, and there's my rise. 1, 2. So since I went up, that's a positive direction, so I have a positive 2 rise. And then you tell me, well, you have to make a right turn. Okay, I'm going to make a right turn. And I'm going to take 1, 2, 3 steps right, and then I will end up at the next point on my line. So since I took a right turn and I traveled in the positive direction to the right, my run is going to be 3. So you can count out these slopes on a graph. So if you're given a picture of a line and asked to find the slope between 2 points, I would advise just counting it out. It's a good skill to have, and you're certainly going to use it later in this chapter. Right? But if you're given 2 points in ordered pair form and asked to find the slope, I would by all means use the formula. Both of them are important and useful.